This is part two of our 1-1 study guide, and one of the reasons I wanted to break this up into two parts is just the amount of 3D space that we're seeing here, which I know can make some of these things a little bit more difficult to wrap our heads around. So in the first figure that I'm looking at over here, hopefully what you can see is three planes intersecting. If you could think of like a deck of cards, and if you took three cards and almost like a magic trick, if you could slice through them in the middle, and these three cards kind of all intersect in the middle, or you cut little put slices in the middle of them almost to the end of the card, slice it almost all the way through, but so that it doesn't completely slice in half, but then you could sort of lace the three cards together. That is what we're looking at in that figure. Okay, so when two planes intersect, in this case we have three planes intersecting, but when two planes intersect, they're going to intersect at a line, and you can see that line of intersection is here. So we're adding a layer to our dimensions here. If I have two lines, right, remember two lines intersect at a point. The point is the most basic concept we have that we're starting with here, and then we work our way up. If we have 2 points and we connect them, we have ourselves a line. And then if we have two different lines in a plane that intersect each other, now we are moving on to the concept of a plane. Okay, so then what you're going to see, like in this diagram over here, you'll see this dotted line here. This is sort of our X-ray vision. If you're a Superman fan, I'm allowed to see through the plane. If you picture this plane as like a floor, and then what's coming up out of the floor is a pole or a post, right, up to the ceiling. But then this pole continues through the floor, it intersects the floor, and then it goes under the floor down into the basement, let's say, and that's what this dotted line is. So it's like a pole that goes right through the floor, and you're able to see through. So what you're able to see is that A, B, and E are all collinear. They all live on the same line, okay? But E is not coplanar with C and D. He lives outside of this plane E. This point E is below plane N, and this point A is up above plane N. B, C, and D are all in plane N. So for me, the way I conceptualize this, it makes sense, is I picture like N as being the floor, okay? So N is the plane of the floor. I put 3 points on the floor, B, C, and D. But then up on the ceiling somewhere, or up above the ground, I have a point A floating up there. And then down in the basement, which would not be in that floor, would be point E. Okay? So let's see if we can answer some of these questions. Name the intersection of plane N and line AE. Okay, so line AE is this line that we said before is going through the floor into the basement, and the point of intersection would be point B. So I'm going to use my point symbol notation to say point B is where they would intersect. You have a line and a plane intersecting each other at that point. Name the intersection of BC and DC. Okay, so this is a little bit easier. BC and DC, where do they intersect? They're going to intersect at point C. Okay, and let's erase for a second here. We'll put a question in our Edpuzzle. Does DC intersect AE? Okay, does line DC intersect line AE? Think about that and answer that in the Edpuzzle. Okay, so hopefully you answered no, they don't intersect. Okay, AE, as I was explaining before, is going from the ceiling down through the floor through the basement. So it's down underneath it at this point. See how it's dotted? That's not a point of intersection. This pole is going through the floor and it's underneath CD. CD is in this plane N. So the only way that AE could intersect it is if it went through it, but AE intersects over here on B. So they do not intersect. Now we're moving on to another 3D figure, and if it's helpful, I like to picture this like a shoebox. So if you have a shoebox in your house, maybe you can look at it to sort of think about how this is interacting. You have 4 sides to it, right? Here and here, and these are parallel planes and intersecting planes, right? And then you also have the top and the bottom. So if it's hard for you to see on paper like this, picture a shoebox if you can pick one up. This is the top of the shoebox. This plane down here is the bottom of the shoebox. Okay, if you can picture that. So name the 3 line segments that intersect at point A. So here's point A. what are the three line segments that intersect there? Well, here's one, that's GA. And we think about it, they should all have an A in them, right? BA also intersects there. And then for sure we have DA coming in there. Notice if they're all intersecting at A, they all have A in their labels. Okay. So now let's take a look. Name the line of intersection of planes GAB and FEH. So where's GAB? GAB is the top of the shoebox. So what we do is we label a plane with 3 points. As soon as I name 3 points, I've now labeled a distinct plane. So we could say GHB, GHA, GAB. Any three of these 4 points on top of that shoebox can label the plane. Now the other plane they're asking me about is FEH. Let's see if we can see where that lives. F to E and then to H. So that would define the front of the shoebox here, right? And they're asking us for their intersection. Where do these two planes intersect? And hopefully you can see they intersect at this segment GH here. Okay. And that's their intersection. G is in both of those planes and H is in both of those planes, right? G lives in this plane and so does H, and G and H both live in that plane, okay? All right, let's try this one on our own. Do the planes GFE. I'll try to color them and then I'll let you answer it in your Ed puzzle. Do the planes GFE. So where's GF to E? Same plane that we just colored in. That's GFE. It's the same as FEH. Okay, we just use G to label it instead. It's this plane here. It's the front of the shoebox. Does that intersect HBC? Well, where's HBC? The blue plane over here. Okay, it's the front of the shoebox and a side of the shoebox. Do those two planes intersect? Let's answer that on the Ed puzzle. So hopefully we answered that correctly. Yes, they do indeed intersect. They intersect at DE. Okay, that's their intersection. Now, one thing we didn't have a chance to answer was, what's an example of two planes that don't intersect, parallel planes? Well, how about this side of the shoebox here? All the planes we saw were kind of intersecting each other, right? This plane here is not going to intersect this plane over here. They're not going to intersect each other. They're parallel planes. Like the two sides of the shoebox, they won't intersect, like two opposite walls in a classroom.